Okay, here's your final example on your packet of volume. This time we are switching, when you read this one, you're revolving around the y-axis. So if you want to pause this video and try it on your own, you're welcome to do that and see how you do. But I am going to walk you through it just so you can make sure you understand what's going on here. Starting with a quick sketch. We've got the line y equals 2/3 x and y equals x squared. Okay, so something like this, just for when you are wrapping this around, that's going to be my outside of my figure, and then the inside is created by the y equals x squared, and I'm starting at 1 here, so I know at 1 I'm at 1, 1, which is going to be above my line, and I'm going to wrap up from there to 2, 4, so it's going to be something like this. And then on the other side I'd be up here, something like that. So to take a look at trying to figure out what's going on, we've got like this inner bowl shape or cup shape in here. And then at the bottom we've got the same thing. Let's try to clean that up a little bit. From 1, 1 to... And then on the outside we've just got this larger bowl shape going on. So that's essentially what we have happening here. Geometry is failing, so I only have one straight line. I've got curves to deal with. So I'm going to try to figure out how can I express the volume of this figure. So obviously I am going to have to do radius minus radius, thinking back to what we had just done. We're going to have a big R, and then we're going to have a little r. Except this time, instead of being in terms of x, I should be thinking in terms of y. And the reason is, I'm going to be subtracting those two. The reason is that my thickness of my slice, my washer, if you will, is going to be dy because I'm slicing horizontally. So if I try to look at just one of these slices here, it's going to be something like this, but then it's got that inner circle as well. And it's going to have this little tiny thickness that we're going to call dy. Okay, so for this I'm going to figure out that and sometimes it actually helps to draw one of those slices that I'm taking. The outer circle of my slice is going to be my linear function, as we said, because that's my rightmost function, I guess. So my linear function is my 2/3 x, but I want to redo that because my y equals 2/3 x. I want to have that in terms of x. So if y equals 2/3 x, then that means 3/2 y is equal to x. That's me solving this for x. So I'm going to have 3/2 y for my larger radius. Okay, that's from here out. And then for my smaller radius, I'm going to have y equals x squared, but that means I'm going to take the square root of both sides and say square root of y is equal to my x. So now I've done integral from not sure what to what, because I've got to change my limits to be in terms of y, but I know I'm going to be of 3/2 y squared minus radical y squared dy. So for my limits of integration, let's talk about that. I know I'm going around the y-axis, and it doesn't look like I gave you numbers, but I meant to say on here, sorry about that, from y equals 1 to y equals 4. That's supposed to be given information. Sorry about that. So from 1 to 4. It looks like we're ready to go ahead and integrate this. So integrating, I'm going to get, I've already got the pi pulled out front. Pi times, let's simplify this to 3/2 squared is 9/4. Y squared, radical y squared is y. Dy, pi times 9/4 y cubed over 3 minus y squared over 2, evaluating from 1 to 4. So it gets a little bit messy. I do have to plug in the 4 and the 1 this time. I can't just ignore the 1 like I can a 0. So I'm going to have a pi out front, giving myself enough room here. I'm going to plug in the 4 first. So that's going to be, if I'm plugging in the 4, 9, I'm going to go ahead and simplify with that and say 3. So I've really got 3/4 times 4 cubed minus 4 squared over 2, which is 16 over 2, which is 8. And then minus plug in the 1, so 1 cubed over 4 minus 1 squared over 2. And all of that I'm eventually going to multiply by pi. 3/4 times 4 cubed. 4 times 4 is 16 times 4 is 64 divided by 4 is 16. So 3 times 16, I'm getting 48 minus 8 minus 1/4 minus 1/2. I'm sorry, that's 3/4. I made a mistake right here, because that should have been, I canceled my 9 and 3, but had a 3 right there, so that's a 3/4 minus 1/2. Let's go ahead and change that to 3/4 minus the 1/2. We could write it as 2/4, so I could subtract those and get 1/4. So I've got 40 minus 1/4, all multiplied by pi, which is, I suppose you could say 39 3/4 times pi. I really don't like mixed numbers, so I'm going to go ahead and say that 40 over 4 is actually 160 over 4. I'm subtracting 1 over 4, multiplying that by pi. So final answer, final answer is 159 pi over 4 units cubed. And yes, that one took a while. So that was number 8 on your example page. Now, just to help you, I know there's one problem in the My Math assignment that's going to confuse you. So I'm going to work through an example right now. It's going to give you a curve. It's nothing different than this, but it is asking you to wrap around a different axis. So here's my example for you with wrapping around a different axis. We're going to take the curves. Y equals, this one's not on your page, but you could put this at the bottom there. Make this example 9. Let's take the curves y equals 3 radical x, the line y equals 6, and the line x equals 0. We're going to take the region bounded by those lines, and we're going to wrap it around 2 lines other than the axes. Now, if you want to start off by wrapping around the x-axis and the y-axis, those are also part of the question in the My Math Lab assignment. So you could do that as well. I'll just give you the setup for that and the answer. So let's do a quick sketch. And what you're going to notice with this one is that for the square root of, when your x is 1, I'm just putting some numbers in here real quick. When x is 1, your y is actually going to come out to 3 times the square root of 1, which is 3 times 1, which is 3. So I'm going to get a 1, 3, and then when your x is 4, you get square root of 2, and then you're going to get 6 for that. So that's my 3 radical x curve. And then I've got my y equals 6, line y equals 6, which I'm going to put up here, just a horizontal line. And then I've got my x equals 0 as my other bound here. Excuse me. So I'm going to wrap that around, let's just go with the x-axis first. So the first thing I'm going to do here is go ahead and wrap that around the x-axis, which means that I'm going to flip this down. And I'm going to end up with this literally bowl shape, and I've got the inside of the bowl is hollowed out. So if I'm wrapping this around the x-axis, go ahead and take a minute and write down what you think your integral would be. Should be doing a subtraction here. We do have our big R and little r. Okay, if you're checking, you should have pi times the integral from 0 to 4 of my big R, my outside function here, is my line. So my radius is actually always going to be 6. So 6 squared minus my inside curve is my 3 radical x squared dx. So there's going to have some simplification. Final answer, if you want to do it just for the sake of making sure you know what you're doing, final answer there is going to be 72 pi units cubed, as long as I didn't make a math mistake. So if you want to go ahead and, like I said, do that. We're going to talk about a different one. So let's talk about taking this, but instead of wrapping it around the x-axis, we're going to wrap it around the line y equals 6. So still a horizontal line, still integrating with respect to x, but this time wrapping around the line y equals 6. So I'm going back to this curve. I'm going to see if I can give myself a little more room. Nope, not going to give me the ability to separate these. So let's just go ahead and... Oh, not going to let me erase them either. They're stuck together. I'm just going to go over the writing there. We're going to wrap it around, actually, the line y equals 6, which I've already drawn in blue there. So I'm going to go ahead and show that my curve's going to go up here. And I'm going to end up with kind of a horn type thing going on here, like a blowhorn. It would be one way of describing it. And if you look at a slice, any one of these slices, we're not going to have a washer this time. We really just have a disc going on. Just a circle. I just need to figure out how to express that. So this is in a way, so this one is wrapping around the line y equals 6. Volume is going to be a little bit easier because I only have one, I only have to express the radius once. So pi times radius squared dx, I just need to figure out what my radius is. And at first thought, you're going to say it's that function y equals 3 radical x. But remember, y equals 3 radical x. When you say that, you're saying that the radius is the same as the height of my function. And that would be right here. This is 3 radical x. The radius is actually the rest of it up to that blue line. So I'd say that the radius here of my disk is this part, which is actually, if I take the y value of 6, if I take this entire length and I subtract 3 radical x, that's my remaining part right here. So my radius is actually 6 minus 3 radical x. So I'm taking my function, my y equals, but I'm subtracting it from the line around which I'm rotating it. And then, of course, I'm going to square that because that's my radius. So that's your setup here. Integrating from 0 to 4, still not changing that, because I'm going with my x value since I'm slicing this vertically and I'm lining up a whole bunch of slices across my x-axis. So I'm going to go ahead and follow this one through because I do want you to see we're foiling here because we're squaring a binomial 6 minus 3 radical x. So that's not going to be 6 squared minus 3 radical x squared. You can't just square them both separately. What you're really doing right there is I'm going to use a little space over here, 6 minus 3 radical x times 6 minus 3 radical x. And you might want to write that out. Much easier to do that first. In fact, I think maybe we could integrate without doing that. But then we're going to have to do a u substitution. I don't think that's going to work out, or it's going to be pretty messy. So 6 times 6 is 36, minus, I'm going to end up with 6 times 3 is 18 times 2 is 36 radical x plus 9 radical x times radical x is x. So that's all inside my integral. Is I'm going to have integral from 0 to 4 of 36 minus 36 radical x, but I'm going to write that as 36x to the 1/2. Setting up to integrate, plus 9x, integrating with respect to x. And I think at this point I'm actually ready to get rid of the integral. So let's go ahead and get rid of that, figure out my antiderivative. Antiderivative in this case is going to be 36x minus 36x to the 3/2 times 2/3 plus 9x squared over 2, integrating from 0 to 4. We could do a quick cancel the 36 and 3. I've got 12 times 2, which is really 24x to the 3/2. And let's go ahead and substitute in. The 0 I can ignore, but I'm going to have to substitute the 4 in. So I'm going to have 36 times 4 minus 24 times 4 to the 3/2. For this is going to be square root of 4, 2 cubed. Plus 9/2 times 4 squared is 16, substituting that in. So grab a calculator to help you out here at this point, for sure. Pi times, I'm getting 144 minus 192 plus 72 for a final answer of 24 pi cubic units. Okay, main difference there really was that I was wrapping it around, revolving the curve around the line y equals 6. Two other cases here. Of course, we could wrap around the y-axis. So if we're wrapping around the y-axis, that's going to be, again, just a disc, not a washer, because I'm going to have something like this. And I had the line y equals 6 up here. And I'm going to end up with something like this if I'm wrapping around the y-axis. So integrating with respect to y, I'm going to have to switch my function. So I'm going to have pi from 0 to 6 because those are my y values. That's coming right from my coordinate points. What's my y value of this coordinate point? And we figured out a minute at the beginning that was the point 4 comma 6. So I'm integrating from 0 to 6. And then my function, if I take my y equals 3 radical x and solve for x, I'm going to get square root of x equals y over 3, and then I'm going to square both sides. So I'm going to get x equals y squared over 9. Don't forget to square the 3 to get the 9. So my inside is going to be y squared over 9. Don't forget to square that dy. So that would be the correct setup for integrating with this and revolving it around the y-axis. Final answer here is going to be 96 pi over 5 units cubed. Whoops. Okay, get the idea. Units cubed for that one. And then there's one other case, and that's what I want to show you, is what if I'm integrating with respect to y, but I'm wrapping around a different vertical axis. This time we're going to go around the line x equals 4. So other possibility here, same curve, but let's draw this one again. And this time we're going to go around the line x equals 4. So let's sketch in there that same curve that I've been dealing with, starting at 0, 0, going up to 4, 6. And what's going to happen is that is going to flip over here. And then my other line, or my other bound here, was the x-axis. So that's going to come over here. And I'm going to end up with this upside down bowl shape. So if you take any one of these slices, maybe we can actually visualize what's going on here. So taking a really tiny slice, I've got this inner circle here as well. And you might be able to see the ring there. That's what I'm going to try to do, is figure out how do I express the area of that ring by doing the large circle and the smaller circle. So the larger circle radius in this case is going to be my, let's go ahead and put a sort of a vertical line at the line y equals 4, because that's my center, or my axis of rotation. My radius I have to think of as coming from that point. So my larger cylinder, if you will, but my larger circle of that washer is going to be my line x equals 0 reflected, but I'm going from 0 to 4. So that's really going to be a constant 4. So for my larger radius, I've really got a constant 4 in there. I'm integrating from 0 to 6 because I'm going horizontal slices, so my thickness of my slice is dy. And I've got to subtract my smaller radius squared, and my smaller radius is really to my curve, depending on which way you're going, to my curve, which was y equals 3 radical x, and we just said y squared over 9 was the equivalent curve solved for x. So you're going to think it's y, or you're going to think it's y squared over 9, but that's my x value. If you're looking at your graph, your x value, y squared over 9, is this part right here. Oops, somewhere my video stopped there, so just to catch you up, I'm not sure when it stopped. My second radius I figured out was 4 minus y squared over 9. Because this part right here is y squared over 9. I want to go to this line, so I'm really taking the rest of it is 4 minus that part, giving me just this, the radius of that solid that I'm revolving, the inner circle. So I'm going to now go ahead and integrate. You can go ahead and follow, or you can say, I'm good, I've got the setup, that's all I needed to worry about. Because the rest of it is the same thing we've been doing. So from 0 to 4, I'm definitely going to simplify this one first. I'm foiling right now this. I'm not going to write it all out this time. You're welcome to do so. I'm getting 16 minus 8/9 y squared, and then plus y to the 4th over 81. Subtracting all of that. So that is going to involve some simplification there. So I'm going to end up with 8/9 y squared plus y to the 4th over 81 dy. I'm going to go ahead and integrate pi times 8/9 y to the 3rd over 3 plus y to the 5th over 5 times 81 in the denominator, evaluating from 0 to 6. Of course, we can pretty much ignore the 0, and I'm going to end up with, good luck with your calculations here, I'm going to end up with a final answer of 416 pi over 5 units cubed. Double check my math, but that's what I got. Okay, like I said, that should help you with the last MyMathLab problem that I'm giving you in your assignment, and a good question, really just forcing you to visualize some other options.